Hi everyone, note 6.5 are on solving exponential equations, and the key to solving an exponential equation is to try to get all the bases the same. So try to get all the bases the same. Because once I have an equation with the same bases on both sides of my equation, I can set each part equal to, or each exponent equal to each other. So for example, right here, I have 2 to the power of x minus 3, and then I've got 8, and I've got the square root of 2. So I know that 8 is equal to 2 to the power of 3, and I know that the square root of 2 is equal to 2 to the power of 1/2. So I can rewrite this equation right here that I'm looking at as 2 to the power of x minus 3 is equal to 2 to the power of 3 times 2 to the power of 1/2. Okay, but I still have I have one base on the left side and I've got two bases on the right side. So I'm going to use my rules for exponents to figure out what I need to do to make this a single base. And because it's multiplication, I can just add my two bases together. So this is 2 to the power of 3 plus 1/2, and on the left side we've got 2 to the power of x minus 3. Now, essentially, what I'm doing here is I'm just setting the two exponents equal to each other. So I can just say x minus 3 is equal to 3 plus 1/2 right here. So I can say right here, x minus 3 is equal to 3 plus 1/2. And I suggest you draw this over here because I'm going to go back to this, and we're going to use the laws of logarithms to see why this is a possibility for us to do. So if I add 3 to both sides, I end up getting 6 plus 1/2, and 6 plus 1/2 is 12 over 2 plus 1 over 2, so x is equal to 13 over 2. Okay? But really quickly, I just want to show you guys why using laws of logarithms we're allowed to do this. So what I would do is I would log both sides. So I get log base 2 of x minus 3 is equal to log base 2 of log base 2 to the power of, log of 2 to the power of x minus 3 is equal to log of 2 to the power of 3 plus 1/2. The log base is 10 right here because I just randomly, arbitrarily decided to just use 10, and that's an easy thing where I don't have to write the base down. Now, if you guys remember, we can bring our exponents out in front. That was one of the laws that we learned in the last video. So I can say x minus 3 times log of 2 is equal to 3 plus 1/2 times log of 2. And I can divide out the log of 2 from both sides, and then I end up getting this equation that we have up here. Okay? So in number 2, we have different bases. We've got 4 to the power of x, we've got 8 to the power of x minus 3, and we technically have 1 over 16 to the power of 2 minus x. So I want to rewrite all of these bases in terms with a common base, and it's clear that our common base would be 2. So 4 is equal to 2 to the power of 2. Okay, 8 is equal to 2 to the power of 3, and then this 1 over 16 is equal to 2 to the power of negative 4. So what we end up getting here is this 4 is going to be written as 2 to the power of 2, but that's going to be raised to the power of x. So I'm just copying down what I have here. So I'm replacing 4 with 2 to the power of 2. Okay, and then that's going to be multiplied by 2 to the power of 3, and that's replacing 8, but then there still is an x minus 3. Okay, and then this is going to be equal to, this 1 over 16 is 2 to the power of negative 4, and we still have this 2 minus x here. Okay, so then if I were to rewrite this whole left side right here, it's multiplication. So since it's multiplication, we multiply, we should add our exponents. So this is technically saying 2 to the power of 2x plus 3 times x minus 3, and that's going to be equal to 2 to the power of negative 4 times 2 minus x. Okay, now since we have the same base and we have our exponents here, we can set our exponents equal to each other. So we can rewrite our equation as 2x plus 3 times x minus 3 is equal to negative 4 times 2 minus x. And the reason why we do this is we're trying to get to a point where we have a linear equation. Once we have a linear equation, it's super easy to solve. Once we get to this point, the rest is not so difficult. So I'm going to distribute the 3. So I get 3x minus 9. Distribute the negative 4, so I get negative 8 plus 4x. Okay, so then put together my like terms, I get 5x minus 9 equals negative 8 plus 4x. Subtract the 4x from both sides, add the 9 to both sides, and I end up getting x equals 1. Okay, so now let's just do a quick check just to see if this really is going to work. So for our check right here, I am going to replace my exponent with 1. So in the original equation, so 4 to the power of 1 times 8 to the power of 1 minus 3 is equal to 1 over 16 to the power of 2 minus 1. So I end up getting 4 times 8 to the power of negative 2 is equal to 1 over 16 to the power of 1. So then I get 4 over 8 squared is equal to 1 over 16, because remember the negative exponent means we put it in the denominator. So I get 4 over 64 equals 1 over 16, and if I were to simplify this, I get 1 over 16 equals 1 over 16, so it checks. It works out for us. Okay? All right, so now taking a look at number 3, number 3 is a little bit different because of this minus sign. So 3 to the power of x plus 2 minus 3 to the power of x equals 72. We don't have any rules for exponents with subtraction here. So we need to be a little bit creative about how we're going to solve a question like this. So instead, what I'm going to do is I'm going to break this up. I know it's I have addition in my exponent, so I know that essentially it's just 3 to the power of x times 3 to the power of 2. And then I'm just going to copy the rest of this down. Minus 3 to the power of x equals 72. Okay, now when I look at this right here, I see there's a 3 to the power of x in common with both of my terms. So what I'm going to do is I'm going to factor that out. So I end up getting 3 to the power of x times 3 to the power of 2 minus 1 is equal to 72. So I'm going to evaluate what I have inside of here because that's a nice easy number. So I get 3 to the power of x times 3 to the power of 2 is 9. 9 minus 1 is 8. So I get 3 to the power of x times 8 equals 72. Okay, now what I'm going to do is I'm going to divide both sides by 8 to get this 3 to the power of x alone. So I end up with 3 to the power of x is equal to 72 divided by 8 is 9. So 3 to the power of 2 has to be, 9 is 3 to the power of 2, so x has to be 2. And that's my answer for this question right here. Okay, and same thing, we can do a check just to see what happens. So for my check right here, I would do 3 to the power of 2 plus 2 minus 3 to the power of 2 equals 72. Okay, so I get 3 to the power of 4 minus 3 to the power of 2 equals 72. Then I get 81 minus 9 is 72, which is true that 72 equals 72. So x equals 2 is the solution to this equation right here. Okay. All right, so for number 4, it says an investment of $2,500 grows at a rate of 4.8% per year, compounded annually. How long will it take for the investment to be worth $4,000? So if you remember from last year, we learned that compound interest when it's annual will be A times the principal, or A equals the principal times 1 plus your interest rate to the power of t. Okay, so here our P, our initial amount is $2,500. Okay, our interest rate is 4.8%, so it's 0.048. And it's compounded annually, which is why we're allowed to use this right here. And we want to figure out how long it will take for the investment to be worth $4,000. So I want to solve for t. So this is going to tell me right here that A is equal to my principal, which I now know is 2,500, times 1 plus 0.048 to the power of t. Okay, so I can simplify this and I can say it's 2500 times 1 plus 0.048 is 1.048, all raised to the power of t. And now I want to know how long it will take for the investment to be worth $4,000. Okay, so I'm going to set $4,000 equal to $2,500 times 1.048 to the power of t. So now I'm going to divide both sides by 2,500 because my goal is to get this t alone. So I want to get rid of this 2,500 right here. So if I were to go through and divide 4,000 by 2,500, I get 1.6. So here I get 1.6 equals 1.048 to the power of t. Okay, so now when I get to this point right here, we're going to use our rules for logarithms to solve for t. Okay, so to get this t out of here, out of this exponent, the only way that I can do it is if I log both sides. And the reason why I'm going to log both sides is once I log the right side right here, we can use our law of exponents that we know from before, where log base a of m to the power of n is equal to n. I can bring this exponent out right here, right in front, which is exactly what I need to do in order to get this t out of this exponent right here. So I'm going to log this side, but whatever I do to one side, I do to the other side. So I end up getting log of 1.6 is equal to t times log of 1.048. So now to get this t alone, I can just say t is equal to log of 1.6 over log of 1.048, which is different than log of 1.6 minus log of 1.048. This is different because I'm doing the actual log to both of them as opposed to log of just 1.6 over 1.048. That's not the same thing, okay? So I'm going to go ahead and type that into my calculator, and I'm going to actually use the Desmos scientific calculator because it's a lot more straightforward than the one that's on the computer here, okay? So in order to be able to do this, I'm going to open up my scientific calculator on Desmos, and I'm going to type in a fraction right here, and I'm going to type in that I want log. So I'm going to go to function, and I'm going to go to log, and I want log of, if I take a look at what I have here, it's 1.6, so it's log of 1.6, but you probably want to type in the 1.6 inside the log. So log of 1.6 divided by, and then here I'm going to do log of, right here I'm going to type in 1.048, and then your answer shows up here. So my answer is about 10 years. So t is equal to approximately 10 years. So it takes about 10 years for this investment, this $2,500 investment, to reach $4,000. Okay? Now, question number 5 is pretty tricky, so I would like for you to please make sure you're paying really close attention to 5 and 6, because these are a little bit more challenging than some of the other questions that we have going on here. Okay? So in number 5, I want to show you guys 2 different ways to solve this. So you're going to want to write pretty small. So method number 1 that we have here, the first thing I'm going to do is I'm going to break this up, this 2 to the power of x plus 1, into 2 to the power of x times 2 to the power of 1. Okay? And the reason why I'm going to break this up, normally we would put it together into one exponent, is because my bases in this question are different as opposed to being the same in the previous questions that we've looked at. So I'm going to say this is 3 to the power of x times 3 to the power of negative 1. So here I end up getting 2 to the power of x times 2, because 2 to the power of 1 is just 2, is equal to 3 to the power of x times 3 to the power of negative 1 is 1/3. So it's times 1/3 here. Okay? So to get rid of this times 1/3, I'm going to multiply by 3 on both sides right here. So I end up getting 2 to the power of x stays that way, times 6 is equal to just simply 3 to the power of x. And I'm going to get this in a way so that I can have all my x's on one side. So I'm going to divide by 2 to the power of x because that's the only way that I can get rid of this x over here. So what ends up happening is I end up getting 6 equals 3 to the power of x over 2 to the power of x. But I can rewrite this as 3 over 2, all of it being raised to the power of x, because if both are being raised to the same exponent, then I can just put the base as 3 over 2 and the whole exponent is to the power of x. Now that I've done that, I have a single x, which is a lot easier to solve for now. I'm not going to have to worry about x's in my answer. Now I can just isolate my x. So what I'm going to do is I'm going to log both sides. So I'm going to log the 6, and I'm going to log the 3 over 2 to the power of x, okay? And by doing that, I can now bring this x out in front. So that turns into log of 6 is equal to x times log of 3 over 2. Okay, now to get the x alone, I can just say x is plain and simply equal to log of 6 over log of 3 over 2. Okay, so to type this in, I'm going to type in a fraction again. I'm going to go to function, type in log. I want log of 6. And then in the denominator, I want log of 3 over 2. So I'm going to type in another fraction where I've got 3 over 2. And my answer here is 4.419, okay? And since it's said to round to 3 decimal places, we'll say it's approximately equal to 4.419. Okay, that's one method. Now, I would like to talk to you guys about a second method to be able to solve this question right here. So try to fit this in. We're going to have method number 2. So I'm going to start right from the beginning. So 2 to the power of x plus 1 is equal to 3 to the power of x minus 1. And what I'm going to do is I'm going to log both sides right from the beginning. So I'm going to say log of 2 to the power of x plus 1 is equal to log of 3 to the power of x minus 1. Okay? And when I do that right here, I'm allowed to now bring my exponent right in front. So this turns into, don't forget your brackets, it's really important that you have it, x plus 1 log of 2 is equal to x minus 1 times the log of 3. Okay. So now I'm going to distribute the log 2 to everybody. So I end up getting here x log 2 plus, and then if I multiply log 2 by 1, I get log 2, okay, equals, now I'm going to distribute the log 3 through, so I get x log 3, and then log 3 times negative 1 is minus log of 3. Okay, now in order for me to be able to solve this type of a question, I need all my x's on one side and everything else on the other side. So I'm going to move my x log 2 to the right side, and I'm going to move my minus log 3 to the right side. So this is going to say log of 2, and then if I move this to the left side, I get rid of it by adding it. So I'm going to add log of 3. And then on the right side, I'm going to end up having x log 3 right here. This term right here stays on the right side. And then I'm going to subtract the x log 2 from the left side. So I get minus x log 2 right here. Okay, so now the next thing that I need to do is just factor out an x, because remember my goal is to get x alone. So if I factor out this x right here, I end up getting log of 3 minus log of 2. Okay, and then on this side, I'm just going to copy everything down. So this is still going to say log of 2 plus log of 3. And then the last thing I need to do is divide out this log of 3 minus log of 2. So that means that x would equal log of 2 plus log of 3 all over log of 3 minus log of 2. Okay, so let's go ahead into Desmos and let's type this in right here. So I'm going to go to function, type in log. I want log of 2, close my bracket, and then I want plus log of 3. So go to function again, log, and we're going to type in log of 3, close the bracket, and that's going to be over log of 3. So go to function again, type in log. We'll have log of 3, close your bracket, minus, go to function one last time, log of 2, right here, and we end up getting the exact same answer. So it doesn't matter either way you do it, you should end up getting the same exact answer. But I want to show you why these two answers are exactly the same thing. Remember, if you have log of a number plus log of another number, it's just essentially log of the product of those two numbers. So this is log of 2 times 3 on top. And then in my denominator, if I have log of 3 minus log of 2, this is just essentially log of 3 minus 2. Log of 3 minus log of 2 means log of 3 divided by 2. So when I divide those two numbers, I'm going to write 3 over 2. So this turns into log of 6, just like we had before, over log of 3 over 2. So regardless of which method you get, you'll end up getting the same answer. Whichever path you decide to take, you'll get the same answer either way, okay? All right, so let's take a look at our last question that we have here. And it says 3 to the power of 2x minus 10 times 3 to the power of x is equal to negative 9. So this one right here, we need to be a little bit creative when we do this type of a problem, okay? So I'm going to just go ahead and copy it down. So 3 to the power of 2x minus 10 times 3 to the power of x equals negative 9. So the first thing I'm going to do is I'm going to let u equal 3 to the power of x right here. So when I do this right here, I want you guys to notice that this 3 to the power of 2x is technically 3 to the power of x squared. Okay? And since 3 to the power of x we said is u, this is technically u squared. Okay, minus 10, and then this right here is u, okay, so we can say that this turns into 10u equals negative 9. So I'm going to go ahead and get everything on one side, so I get u squared minus 10u plus 9 equals 0. So I'm going to solve this for u, and I'm going to have u minus 9 and u minus 1. Which means that u is 9 and u is 1. Okay, so now that I know that u is 9, I can replace this u right here with 9, and I can say 9 equals 3 to the power of x. Okay, and then I also know that u is 1, so I can replace this u with 1 and say 1 equals 3 to the power of x. Okay, so then here I get 9 equals 3 to the power of 2. 3 to the power of x, but I know that 9 is 3 to the power of 2, so x equals 2 is one of my solutions. Okay, and then for my other solution, I know 1 is 3 to the power of 0, so that'll be equal to 3 to the power of x, so x equals 0, and that's my other solution, and that's how I solve this question right here. Okay, that's it for notes. For solving the notes on solving exponential equations, and we'll get into logarithmic equations in the next video. All right, let me know if you have any questions. Have a great day. Bye.